a postulate is? I feel like we've discussed it before. What is a postulate? Did I get you one?
Nope. Do you have a pencil?
Who can tell me what a postulate is? Hey, there it is. It's a rule that is accepted without proof. So if we think about what a proof means, if you need to prove something, if you were in court and you wanted to prove that you were innocent, what would you have to do? Define it without saying the word proof.
Evidence.
What is evidence?
Something proving. Something showing that you, like, so say I'm on trial for, like, shooting Phil.
Okay.
And Phil got shot in a supermarket. If I show, sorry Phil, I shot you at 7:30 at night in, like, a Hannaford. Say I was in Walmart at 7:30, that is evidence that I wasn't shooting Phil in Hannaford.
Right. That would be a counterexample, right?
Right.
Right. Okay. So, Dominic.
So this will like the theory of evolution. This is a theory, but it's said that it should be accepted.
Right. Yes. So, in math, mathematicians love to prove everything. Like, everything you do in algebra has proof behind it. I took a college course called Abstract Algebra, where we proved every single thing you learn in algebra. So think about everything you learn about in algebra, solving equations, all the different properties, proving it. We literally spent a whole class the one day proving, it was like a 3-page proof, proving why 0 does not equal 1.
What? It's simple because 0 is not 1.
Right, but the thing is in the beginning of time, when someone decided to make the numbers 0 and 1, how do we know that they're not the same thing? So Dominic, that's enough. So there are proofs behind everything that you do. What we're going to learn about today are specific postulates. They do not have proof behind them, but they're enough of a rule for us to say, well, yeah, that is pretty true. So let's look at the first one. Don't worry about the numbers. You do not need to memorize that it's postulate 5 or that it's postulate 6. You just need to make sure you can recognize what it is and what they mean. So the first one says, through any 2 points. There are my 2 points. Put that in the drawing box.
Why didn't we
Dominic,
do one
quiet.
before?
Through any 2 points, there exists exactly one line. Is that true? We already talked about the 1 through 4 postulates. They were our angle addition postulate, our segment addition postulate. Does that have anything to do with what I just said?
No.
Okay. So, does that make sense? Is there any way for me to draw another line through those 2 points?
No.
No. There is going to only be one point that goes through that line. So let's quickly look around the room. Can someone give me an example of something in this room that has 2 points with one line going through it? So, tip of the pencil, eraser. Those are my points. Is there only one line going through it? Sure. Think about your house. Think about your house being a point on a road. Go 3 houses down from your house and consider that a point on that road. Is there only one road that's connecting you from that house to that house?
Well, actually, there could be more than one.
There should be only one straight road connecting you. If we look up here, sprinkler. Is there only one possible line that I can draw that would connect those 2 sprinklers together? Yes. Okay. So number 6 is just the converse of that. Number 6 says a line. So here we're starting with the line. So a line contains at least 2 points. Why do you think we're only using the word at least here?
Because it could be more than 2.
How many more?
Infinity?
Yeah, there could be an infinite
In
number
fact,
of points.
They're all an infinite amount.
Right, there are an infinite amount of points on this line. There's a point here, and I keep doing that as much as I want it. Okay, so 5 and 6 are just converses of each other. Number 7 says if two lines intersect, so if we got two lines, in this case I have line N and line M intersecting, then their intersection is exactly 1 point. Is that true? Yeah. Okay. There's no way to get those two lines to intersect at more than 1 point unless we turn the line into a curve. Then it wouldn't be a line anymore. So two lines always will intersect at exactly 1 point. Number 8, through any 3 noncollinear, what does noncollinear mean again? Not on the same line. So right here I've got 3 noncollinear points. Through any 3 noncollinear points, there exists exactly 1 plane. Remember when we talked about naming a plane, we said you needed to have a minimum of 3 points to name the plane? So when you name the plane, you would call that plane NPN. Okay, so let's think about that. Do I have, let's ignore this sprinkler. So the other 3, right there's 1, 2, 3 sprinklers. What plane would those 3 sprinklers be on?
S1, S2, S3.
What plane? The ceiling is a plane, right? Okay, so through any 3 noncollinear points, there's exactly 1 plane. 9 is the converse. It's going to be the same diagram, it's just we're working backwards. Number 9 has us starting with the plane. And again, why are we using the word at least? Because there could be an infinite number of points on that plane, because technically planes go on and on and on forever in 2 dimensions. So a plane contains at least 3 noncollinear points. Very good so far. Number 10, if 2 points are on a plane, and I've got 2 points on the plane, guys, quiet please. Would it be true if I were to connect those 2 points with a line, that the line would also fall on the plane? Yes. So let's think about this point of intersection right here above Ashley's head. That point right there. And then let's think about the point of intersection directly above, I don't know if that's Zach's or Alex's head, one of those 2. Okay. Those 2 points are on the ceiling. This line, is that also on the ceiling? Yes. Okay, and that's what postulate 10 says. Now postulate 11, do your best. If 2 planes intersect, can you make the intersection of 2 planes? Doesn't have to be perfect. So if 2 planes intersect, would it be true that the intersection of them is a line? Yes. 2 lines intersect at a point. 2 planes intersect at a line. So there's our line. How'd you guys do with your artwork? There you go. See where the artists in the group. Not so bad, not so bad. Okay? All right, so now we're going to use these postulates to look at a diagram and decide whether a statement is true or false. Or can we assume something? Is everybody good on the back? Okay. So, given the diagram, can we assume that points A, point H, well, there's not a dot there. How do I know it's a point?
It's intersected with.
Two lines intersect at a point. Point J and point D are collinear. Can we assume that? Yes. They're on the line. Can we assume that points F, define F, H, and B are collinear? Yes. So for your homework, you're going to be doing a lot of true falses. This is what's going to be happening. Can we assume points E, J, and C are collinear? Yes. Can we assume that points G, F, and H are collinear? No. Now, really quickly, just looking at this one, what if it just said G and F? Could G and F be collinear?
Yeah.
Yeah, because any two points make a line. Even though they're not on a line in the diagram, we could still assume that they are collinear, because any 2 points can be collinear. Are points A, B, C, D, and F coplanar? Yes. Is the intersection of line FB and line AD point H? Yes. Is the intersection of line EC and line AD point J? Yes. Ooh, what does that symbol mean again? Not collinear. Congruent, right? Let's figure out where these angles are.
I thought they meant approximate.
Nope, 2 squiggles is approximate. So angle AHB is this angle right here. And angle HJC is this angle right here. Can we assume that those 2 angles are congruent? No, I can't assume it. Is it giving me the diagram or the little marking of congruent angles? No, so we can't assume it.
You can tell it is.
If it showed us this, then we can assume congruency.
But it is like that because the way the lines are set.
We don't know for sure. We can't assume what is not told to us.
But we can see
Dominic,
that it is.
stop. So that would be a no. How about line FB and line EC? Will they never intersect? Can we assume that they will never intersect?
Yes.
What type of lines never intersect? Parallel lines. Anywhere on here is it telling me that I have parallel lines? No. So if these lines continued on and on and on and on and on forever, they may eventually intersect. I don't know. I can't assume that they would never intersect because nowhere in that diagram is it telling me that they can't. Okay? All right. So what I would like you to do is please grab yourself a practice space. We're going to try some